After, we got to start. Hang on. Okay, so we're going to talk about simplifying fractions. Now, these fractions may have variables in them. They're going to talk about all different sorts here. So the first one's pretty easy because this is like what we've always done. But I don't want to just jump to the end. Let's talk about what we do because that's going to explain exactly how we're going to simplify all fractions. How do we simplify this fraction? Yes, ma'am?
We find the factors of both.
Okay, so we're going to look for the GCF of both, the greatest common factor that both of them can be divided by. And what is it for both 30 and 48? Okay, so we can divide 30 by 6 and we can divide 48 by 6. 30 divided by 6 is?
5.
And 48 divided by 6?
8.
So we get 5/8. That is the simplified version of this fraction. And we're going to use that same strategy to simplify some things that have variables in them as well. You don't, what? Did you say you don't understand?
No, I do.
Okay. All right. So we're going to do the same thing now, is we're going to look for the GCF. But when we look for the GCF, we're not going to look for just the GCF of the numbers. We're going to look for the GCF of the letters as well. So let's decide what is the GCF of these two monomials.
3.
Okay, so 3. Anything else?
X, y to the second.
X, y to the second. Notice that they both have at least one x, and they both have at least two y's. So what I'm going to divide both the top and bottom by is 3xy squared. So on the top, we've got 9 divided by 3, which would give me
3.
and x divided by x. What would give me, what was x divided by x?
0.
Well, when we get x, right, we're going to get, if you had x divided by x, that just ends up as 1. So we got a 1. And then y to the third power divided by y to the second power
Y.
is going to be just like this. Y to the third power divided by y to the second power becomes y to the 3 minus 2, which is just y. So we got a y up there. Now on the bottom, we've got 15 divided by 3 is?
5.
And x squared divided by x
X.
would just be 1x. And if you're having trouble with that one, it's just x squared divided by x would be x to the second minus 1, which would just be x. And then finally, we've got y squared divided by y squared.
That's 1 again.
Just 1. Now, just to clean this up here, on top, that simplifies to what?
3y.
And on bottom?
5x.
Perfect.
Do we have to show that we're working on homework?
For sure.
Even the x divided by
I don't care if you don't show me this part, but I do need to see what is that GCF that you're dividing by, and what did you get each time when you divided. So I only write this to illustrate if you were having difficulty dividing two things. You're like, why is y to the third power divided by y squared? Why is that just y? Well, that's the reason why. Okay, so let's talk about these two. What is the GCF for these two?
5 AB.
I'd go bigger than 5.
15 AB.
Okay, so 15, they both 30 and 45 can be divided by 15, and they each have at least one A, and then they at least have one B. So we're going to do that division right now, and 30 divided by 15 is 2. And a to the third power divided by a, that would be a squared. B divided by b,
1.
that would just be 1. And then on the bottom, we've got 45 divided by 15.
3.
That would be 3. A divided by a,
1.
that would be another 1. And then b cubed divided by b,
B squared.
that would be b squared. Let's clean that up now. What do I have on top? And on the bottom? 3b squared. Done. Well, on the top, we did 30 divided by 15, which gave me 2, right? And then we did a to the third power divided by a, which gave me a to the second power. And then we did b divided by b, which something divided by itself will just give me 1.
Oh.
All right, moving on to D. So what do we have as the greatest common factor for 8 and 96?
8.
8. So we're going to divide both top and bottom by 8. What is the greatest common factor of x and x cubed? Okay, so we've got 1x, so we've got 8 and an x. How many y's should I put in here? 1. And z? Just 1 z. So let's do the top and bottom now. 8 divided by 8 is? 1. X divided by x is? Y divided by y is? Z divided by z is? Well, that's kind of nice. That's just going to end up as 1. And on the bottom, we've got 96 divided by 8.
12.
That would be 12. And then x to the third power divided by x. X squared. So again, x to the third power divided by x would be x to the 3 minus 1, bless you, which is x squared. Z to the third power, oh, I'm sorry, skip my y's. Y divided by y, that's 1. And z to the third power divided by z, z squared. Let's simplify this. The top became 1. What does the bottom become? Okay, so I think we're on to the next one now. Okay, so here's kind of a cool little rule that we've got, and this is about the law of exponents. So when we had two things that had the exact same base, like x, let's say x to the 5th power divided by x to the 3rd power. That might look like this. Here's another way of writing that exact same thing. These are exactly the same. The reason that we're allowed to do what we are doing now is because they have the exact same base. If something has the exact same base, then you can just go and write that base down and then do 5 minus 3, which would be x is equal to, which is equal to x squared. Same exact thing. Now, we can use this rule even if it's not a variable. So check it out. Look at A. We've got 2 to the 8th power divided by 2 to the 5th power. Now you might sit there and want to calculate what 2 to the 8th power is and then divide it by 2 to the 5th power, but I would say you're being a little bit crazy there because these two things have the same base. I'm only going to take it one step further because I can actually calculate what 2 to the 3rd power is. What is 2 to the 3rd power? 8. 2 times 2 times 2 is 8. So to work this out. Now, somebody in another class had a really good question. They said, Mr. Hire, dude, why don't you just do this? Why don't you do 2 divided by 2, and you would get 1, and then you could deal with them? Well, the truth is you can't do that first because we do not do division before we do exponents. When we have to deal with the exponents first before you can deal with anything else. Remember, the order of operation in math says exponents come first. All right, let's try to get through 2 more. Let's talk about what we've got going on here. What's the greatest thing that we can divide the numbers by? 1. So the greatest thing that the top and bottom, there's a 1 on the bottom. The greatest thing that they have in common is a 1. What about the greatest amount of x's? So let's do this division now. On top, 5 divided by 1 is 5. X to the 3rd power, divided by x to the 3rd power is 1. X to the 3rd divided by x to the 3rd would be x to the 3 minus 3, which is x to the 0, and that is equal to 1. Okay, so now we've got 1 divided by 1 is 1, and x to the 7th divided by x to the 3rd? X to the 4th. Now I'm just going to clean this up. 5 times 1 is 5. 1 times x to the 4th is just x to the 4th. Okay, let's look at C, and I think we'll stop at C, and then I'll probably just do the rest of these, well, depending on our time. We'll see how we go, but I may be doing the last 4 on the video, and then I will upload that tonight, and then you guys can finish based on that. All right, when you have a fraction that is being raised to an exponent, notice the whole fraction is being raised to an exponent because it's in parentheses. That means both the top and the bottom are being raised to that exponent. So another way to write this would be 2 to the 3rd power is being raised to the second power, and the 3 is being raised to the second power. Well, the bottom should be pretty easy, right? What's 3 squared?
9.
And the top is like 2 to the third power times 2 to the third power, which becomes what?
T to the 6th.
T to the 6th, because that's t to the 3 plus 3, which is equal to t to the 6th, and we still have a 9 on the bottom. Are we okay with that? Again, not a terrible lesson. That's why it was a great lesson to work in today.
We don't have to show all that, or we do?
I want to see, at least in these first lessons, that this is what you're doing, because this is going to get uglier.
Okay.
And once you have shown me the steps, then I feel comfortable that you know how to do this. So when it gets uglier, you don't have to show as many more steps. You already have this. You've done it so many times. You know what's going on. Okay, our last 4 problems here. We're going to look at getting a GCF for this monomial. Looking at both the top and bottom, it looks like 24 and 32 both share a factor of 8. S to the 4th power and S both share a factor of S. And t to the 3rd power and t to the 5th power both share a factor of t to the 3rd. So both the top and bottom I'm going to divide by 8st cubed. On top, 24 divided by 8 gives me 3. S to the 4th power divided by s to the 1st power is s to the 4 minus 1, which would give me s to the 3rd power. So we've got s to the 3rd power. T to the 3rd divided by t to the 3rd would just be 1. So on top we've got 3s to the 3rd power. On the bottom we've got 32 divided by 8 is 4. S divided by s, which is 1. And t to the 5th power divided by t to the 3rd power is the same as t to the 5th minus 3, which would give me t squared. So we've got 4t squared. So 3s cubed over 4t squared. Moving on to B. All right, so the craziness in this one kind of comes in this area right here. So this is kind of the difficult part that I'm just going to kind of work out here first. So I'm going to leave this 5x over 4y squared. We're going to see what we can do with this exponent, because we can't do any multiplying, any division, anything like that until we've dealt with that exponent. Now notice here that everything is being raised to the 3rd power. That means that this 2 is being raised to the 3rd power, this y is being raised to the 3rd power, and that x squared down there is also being raised to the 3rd power. So what we get is, this is multiplication, and we get 2 to the 3rd power, y to the 3rd power, and in the bottom we get x squared to the 3rd power. Now, when we simplify this a little more, we get 5x over 4y squared, and then we get 2 to the 3rd power, which is 8, 2 times 2 times 2, y to the 3rd power. Now x squared times x squared times x squared times x squared is x to the 2 plus 2 plus 2, or x to the 6th power. So in the denominator we get x to the 6th power. Now what's great about this is that, yes, we could put all of this together. You could multiply straight across the top and straight across the bottom and get one big thing and then start working on it. But one of the things we can do when we have 2 fractions that we are multiplying is we can start cross-canceling. So like, let's say we look at the 4 and the 8. We could cross-cancel them. We could say that 4 goes into 4 once and 4 goes into 8 2 times. We can cross-cancel the y's as well. Y squared is on the bottom here, and there's a y squared that's a common factor there. So I could say y squared goes into y squared once. So notice I've got 1 and 1 on the bottom there. And up here, y squared would go into y cubed and only leave 1y left over. So let me rewrite this before it gets too messy. We've got 5x left over on top, and there is a 1 left below there because we had 1 times 1. Over here, we've got 2 times y, because that's all that was left over. There was a 2 and a y, and in the bottom we've got x to the 6th power. Now, we didn't just cross-cancel in that direction, we also have an x here and here. So we can cross-cancel one of the x's here with one of them here, leaving us just 5 over 1 times 2y. And in the bottom here, one of those x's to the 6th power got canceled out, so we just have x to the 5th power left over. All right, our final step there, multiplying straight across the top now is a little bit easier. 5 times 2y is 10y. And on the bottom, 1 times x to the 5th power is just x to the 5th, leaving me 10y over x to the 5th power. Okay, 2 more here, and it looks like we're going to have some multiplying going on again. So notice here our situation is that we've got this area here where everything is being raised to the 2nd power. So that's got to be dealt with first, because we can't cross cancel, we can't divide, we can't do anything like that until that's done. So this squared up here is going to apply to the a squared, it's going to apply to the b, and it's going to apply to that c cubed on the bottom. So first we do the a squared. So that a squared is then going to be squared. And the b is also going to be squared. And on the bottom we've got a c cubed that's going to be squared times c to the 6th power a b cubed. So all that left side is still a little messy. Let's just deal with that. That a squared is going to become a to the 2nd power times a to the 2nd power, which becomes a to the 4th power. B squared is just b squared, and c to the 3rd squared becomes c to the 3rd times c to the 3rd, that becomes c to the 6th power, times c to the 6th power over a b to the 3rd. Good news here, this c to the 6th power and this c to the 6th power are going to cancel each other out when we cross cancel. We're going to have 2 of the b squares will go into here. They will also go into here, leaving 1b left over down there. A will go into a once, and one of the a's up here will disappear, leaving a to the 3rd power. So look, if you look at the top here, the only thing that's left in the top is a to the 3rd power, and in the bottom, the only thing that's left over is b. So all of that simplifies, even though it was a whole crazy mess there, it just simplifies to a to the 3rd power over b. And then finally, last but not least, and I think this one can get a little bit confusing if we don't take a moment with it. So we've got zn to the 3rd power. That means that this is going to be multiplied times itself 3 times. So zn times zn times zn. Well, they have the same base. So that's z to the n plus n plus n. If you think about it, we're just looking at the top there. That's just this. All we're doing is that right there, because that's the same thing as z to the n times z to the n times z to the n. Same base, just add their exponents. So the top here is just going to end up as z to the 3n, because it's n plus n plus n. That would be 3 n's. So we get z to the 3n. That's on top. On the bottom, we've got z to the n times z to the 3rd power. So remember that when we've got z to the n times z to the 3rd power, and we multiply them, they have the same base. I almost said same base. The same base there, so that becomes z to the n plus 3, because we remember we add their exponents when we're multiplying. So we get z to the n plus 3. Now it almost feels like there's nothing else. Oh, sorry, let me correct that. That should look like this, z to the n plus 3. Okay. So now it almost looks like there's nothing left to do there, except for when we divide two things with the same base. Notice that they have the same base. They're both z's. So what we do when we've got things with the same base and we're dividing them, so we've got, remember, that's z to the 3n divided by z to the n plus 3. And remember what we do when we've got two things with the same base and we are dividing, it means that we are going to subtract their exponents. So what we end up with is z to the 3n, and we're going to subtract n plus 3. And now we need to keep that in parentheses there because we're subtracting the n and the 3, both parts there. All that ends up happening with this there is that n is going to be distributed to both of those things, and we get z to the 3n minus n minus 3. That negative has been distributed throughout, and then only one more step we've got here. We've got 3n minus n. That is definitely something I can do. 3n minus n would just be 2n minus 3. So we end up with z to the 2n minus 3. So a lot of work there to get to z to the 2n minus 3. But we had to look at what do we do with those exponents. And that's it.